From Communicating Science, this is the narrated PowerPoint on getting the story, telling the story, the science of narrative, the narrative of science.
Now, in the next article, the author Forbes is talking about the idea of using narrative in science writing. In other words, storytelling. That's what she's interested in. The extent that we should be teaching students to use narrative in telling the story of science. And uh, isn't and so a question I pose: isn't an experiment to some degree a narrative? A lot of times it isn't written that way. A lot of times when students do lab reports on experiments, what they do is basically they fill out a form, and we've all done that. I did that when I was an undergraduate. But if there at other times, it could be that teachers and professors and so forth may have their students do something like they sit down and they actually write what they did as a narrative, and it's a way of humanizing what we're doing and making it more accessible. So, and she also mentions using figurative language, which I have taken and put into divided into two different types. What these are tropes and figures. Usually, tropes are referred to as metaphors, but a metaphor is a very specific type of application. An atom is a miniature solar system, is a metaphor. An atom is like a miniature solar system, is a simile. If you have something like as the uh, planets orbit the sun, the subatomic particles orbit the nucleus of the atom. That's an analogy, and figures are metaphors or tropes depend upon word plays, often the turn of a word. There's other types, of course, of tropes like personification, uh, messenger RNA, or something like that, where you assign the tropes of a human to something like RNA. um, and then figures are usually syntactically more complex. That is, they depend more upon the structure of a sentence. With analogy, something you're familiar with, and this is from testing, is that A is to B as C is to D structure. And that actually goes back to Aristotle as well. He was the first one anyway. We have who use that type of model to describe analogy. So, and that's something that I've written about in my book, Motives for Metaphor in Scientific and Technical Communication. So, and I'm going to talk a little more about some of that as it relates to stem cell research, and starting up on the next slide or so. Forbes also brings up that idea of objectivity in scientific and technical writing, and whether or not it's is it even possible to be objective. And a lot of times that might be an argument against using narrative in scientific writing. That when what we're used to of thinking about in scientific writing, that which depends more upon the MRAD structure, or a scientific article that is structured according to the introduction, a method section, a results section, and a discussion section, lends more objectivity to writing about science. So, um, this idea of objectivity in writing, though, has to led in technical communication to talking about ethics. That is, if you're trying to be supposedly completely objective about a piece of scientific writing, I mean, how can you do that when what's being written about is something that is completely unethical? How can you be objective about something that's completely unethical. And that's something that we'll get into in more detail actually later in the semester. So, and what she's trying to do is to get away from this idea of scientific style as a reality independent of its linguistic formations, or in other words, uh, a lot of theorists have said, and this when I say a lot of theorists, I'm talking about people in English language studies, I'm talking about in psychology, I'm talking about in education, have said that all language and all thought is metaphoric. In other words, we understand new information in terms of what we already know. So, um, and she's saying that if you try to think of science as being completely objective, then you're thinking of it as a reality independent of its linguistics formations. And she's saying that you can't do that, and that's another reason that we should think of further humanizing science by thinking about it as a narrative. When we get into this area of thinking about science, we're really getting into a field of study called science studies, and I've listed some of the major divisions of science study. The original one, going all the way back to the ancients, is certainly philosophy of science. In philosophy of science, we have Aristotle laying down the scientific method of observation and drawing conclusions based upon that observation. And of course, that's advanced through the ages. And then the other three, history of science, sociology of science, and rhetoric of science, really started to come into being in the 1970s. Of course, history of science, there are individual historical works about biographies of scientists, for example, prior to that, or about scientific movements, or the beginning of what we think of today as modern science in the 17th century, with Sir Isaac Newton theorizing that the same um, force that causes the apple to fall to the ground is the same force that causes the planets to orbit the sun. And he didn't have any empirical proof of that really until we had the first spacecraft go off into space and start taking pictures. But well before that, it came to be accepted by educated people. But he was not really too far at that time from the type of resistance that Copernicus and Galileo had met up with when Copernicus first proposed that we live in a heliocentric system, that is, a sun-centered system where the planets orbit the sun rather than the other way around. Everything orbiting the Earth. That didn't work out anyway. And then sociology of science looks at how science occurs in places like laboratories, for example. We found out from actually doing studies, ethnographic studies of labs, that they're a little bit sloppier than they're actually portrayed to be in the scientific article, and things happen by chance, and there are accidents that happen in the lab that sometimes have to cause studies to be scrapped, or perhaps create new knowledge for the scientists. And the difference between those and rhetoric of science is that rhetoric of science is interested in the role that documents and specifically language plays in the creation of scientific knowledge. So what I'd like to do now is to pick up on a couple of ideas from Forbes's article. She talks about in her article about a number of different books that are on science topics and about the role that narrative plays, and she also mentions something about what she refers to broadly again as figurative language, and she also makes a comment about how in rhetoric of science there's not as much attention is paid to um, popular culture. So I'd like to extend that a little further than she does with some research that I've done. This started for me as a pedagogy issue, what I was seeing in textbooks about the teaching of metaphor. And the one at the top is from a textbook that would be appropriate for engineering students, and you can see they recommend using short, simple analogies. Um, but there's no direction about how to go about doing those. And then you have, on the other hand, you have this other one. This is specifically a science writing text, the second one, saying that oh, we shouldn't use metaphors because it might be confusing to our readers. And there were some other texts that I look at that said, oh, we shouldn't use them because it especially could confuse international audiences. So here, this is what brought cloning into the public eye more so than it had been in the past. It actually, scientists have been doing cloning experiments since the 1950s. You go back further than that if you want to talk about it with hybrid plants and things like that. Seedless oranges are clones, for example. Um, but not so much with animals. It does have value to the livestock industry to keep a prize line from dying out. Now, of this group of animals, the two sheep in the on the left-hand side in the left column, the smaller one is the lamb Dolly, who was cloned in 1997. Now, what was unusual about this is that cloning before that had been basically about the same as in vitro fertilization. They would take the nucleus of a cell from one egg and put it in another. The difference was with Dolly, they took a cell from the mammary gland of the donating sheep and put it into the egg cell of the recipient ewe. And so what happened was they took the egg cell from the recipient ewe, they took the nucleus out of that one, and they put in the nucleus from the other sheep, which was just from a mammary gland. Okay, the sheep to the left is what's referred to as a black-faced sheep. She was the recipient ewe. She doesn't get a name the way that Dolly does. And the smaller one, the lamb, that's actually Dolly. You can see Dolly doesn't have a black face. She's a Dorset sheep. And you can see in the photograph in the center that the larger adult sheep, that's Dolly as an adult, and the lamb next to her is one of her babies. So she did grow to be an adult. She was healthy, and she did reproduce normally. She only lived half as long as a sheep ordinarily does. She died when she was about 7 years old. They usually live to be about 15. The reason she died, though, she died of a lung disease that's common among sheep that are kept indoors in research facilities. The reason that she was kept indoors is they were afraid that someone would steal her. I guess in terms of industrial espionage, or perhaps someone who would just want, for whatever reason, the sheep Dolly. But anyway. Now, the foal on the right, her name is Prometea, and she was actually using a similar type of process, actually cloned from one of the cells of the horse next to her. That was her mother. They cloned one of her cells, put it into an egg cell, and then put it in her uterus, where it matured and grew into a horse. Now, so this is what has created all the stir about cloning and about stem cell research, and I was interested in the role that metaphor played in those articles. And what I looked at, the original article that was published in the journal Nature, which is published in England. It was the lead author was a researcher named Ian Wilmot. Um, and so I looked at his article. I looked at other articles that were published in Nature by other scientists, and also in the journal Science, which is published here in the United States, and is also one of the Nature and Science are the two biggest science journals in the world, the two most prestigious. And then I also looked at articles in Time magazine, and these were some of the um, uh, tropes or metaphors that I saw, okay? In figures. You know, a rhetorical question is a figure, and so of course is an analogy. Now, what I was interested in is what was the metaphor or the analogy that was being used principally to describe cloning and stem cell research, especially to the general public. You know, as we know, there was a great deal of resistance to stem cell research and to cloning. And these are the metaphors I found to be to be used the most often. There are programming, deprogramming, and reprogramming, and these refer to what the nucleus does when it's taken from another cell and put into an egg cell. And these, of course, are actually terms that come to us from the computer industry. Um, and there was no central metaphor. Like, for example, Charles Darwin faced a great deal more resistance to the ideas of evolution and so forth, and he used the breeder analogy to describe evolution. But there was no central metaphor like that to describe stem cell research, and my argument was that was part of that's why there was so much trouble. One reason there was so much trouble. Of course, we get into the same types of issues with abortion, that the best types of cells to use are those which are undifferentiated, and those are ones that come from embryos, embryonic cells. So that was also a problem, though of course those were just going to be destroyed otherwise. And to some degree, you meet up with resistance in popular culture as well. The photograph of the woman in the center is her name is Reba. She was from one of the soap operas, and the photograph to the right, to the right, is a photograph of Rita dying. And when Reba was alive, before she died, she was the perfect wife, the perfect mother. Well, her husband was cloned her in his basement laboratory. He was evidently a part-time mad scientist or something. And the clone of Reba, of course, when something is cloned, like when Dolly was cloned, it was her. She started as an egg implanted in the uterus of another ewe, and then she went through natural birth and was a lamb before she became an adult sheep. A lot of times these clones, somehow they are exact copies of us, and they're produced very quickly. They're not, babies and not fetuses and then babies and then children and so forth. And the clone of Reba was evil. She was promiscuous, and a bad mother, all that sort of thing. And then there's Francie over there in the lower left. She was on a TV show called Alias, and I understand that she was somewhat villainous as well. Here's a couple of others drawn from science fiction, where we would hope we would find more reliable presentations of science. But the one on the left is the young man, and that still is a clone of Captain Picard. It seems Captain Picard had visited the civilization 20 years before. They'd gotten some of his cells and cloned him. And now there was some type of conflict between the Star Trek officers and the people on this planet But again, the clone was being depicted as someone who was, if not evil, at least an antagonist. And then, of course, in the slide on the right, that's one more of you would be probably familiar with, George Lucas's Star Wars Attack of the Clones. Thank you, George Lucas. Well, all this changed in 2005, at least in terms of presentation of clones with The Island. In this movie, Scarlett Johansson, Ewan McGregor portray two individuals who are discovered that they are clones and that they've been created on this island to kind of serve as spare parts for the people who had had them cloned. So we see a change in terms of how sympathetically clones are being portrayed. And so the Gallup polls, good reputable organization, posed this question about medical research using stem cells, whether or not it's morally acceptable or morally wrong. Now, before the island in May 2002, 52% said morally acceptable, 39% said morally wrong. You can see the others. Now, that was May 2002. The island comes out in 2005. I'm sure this is just a coincidence, but Gallup does another poll where they ask this question, and we see that now 61%, almost like 9% increase, now find stem cell research to be morally acceptable. And those who feel it's morally wrong, it's dropped 9%. That's pretty significant. So we don't know. I don't know that it's because of the movie or not, but these are facts. So we can hope, for example, that it's better science education. We can hope that people are doing more reading on their own, and perhaps people are also being healed by stem cell research. And so Forbes concludes with, and she cites a number of different scientists and science writers and their works and the role that narrative plays. And she herself looks at the creation of or the beginning of DNA research. But she ends with this quote, and saying that narrative isn't simply a way to dress up, entertain, or sweeten. Instead, the details become the narrative or the story itself, and that's what she's trying to get at here in her essay.
Questions? I'll see you online.